The next property is enthalpy. We know that enthalpy is a combination of internal energy and also the flow work. The enthalpy of air is expressed in terms of enthalpies of the dry air and the water vapor. The amount of enthalpy for dry air will be constant, while the amount of enthalpy for the water vapor can change. The total enthalpy of atmospheric air will be the sum of the enthalpies for the dry air and the water vapor. And it can be given by this expression. Note that this symbol of enthalpy that is written in capital letters representing the unit of kilojoule, while the symbol of enthalpy that is written in the small letter is in the unit of kilojoule over kilogram. Therefore, it will be multiplied with the mass in order for us to get the product in the unit of kilojoule. Again, the properties with subscript A will be referring to the dry air, while the properties with subscript B is referring to the water vapor. Since the atmospheric air is expressed per unit mass of dry air, so we are going to divide this equation with the mass for the dry air. Note that this term gives us in the unit of kilojoule over kilogram, therefore we can assign small letter h. Thus, we will have this equation. And note that mV over ma is equal to the specific humidity. Thus, we're going to have this equation. The value of Hv is equivalent to the value of enthalpy for the saturated vapor at desired temperature. Therefore, we are going to have enthalpy equal to the enthalpy of the dry air plus specific humidity times with the enthalpy for the saturated vapor. This will give us in the unit of kilojoule over kilogram dry air. From MEC351, we know that to find the value of enthalpy for dry air, we are going to use the equation of Cpt. Cp will be the specific heat for the dry air times with the temperature, and for MEC351, the temperature used to find the enthalpy will be in the unit of degrees Celsius. For most cases, the temperature for the atmospheric air can be in between the range of minus 10 degrees Celsius up until 50 degrees Celsius. Therefore, we can find the value for Hg by using this equation. The value of 2500.9 is for the temperature approximately equal to 0 degrees Celsius, plus with CPV-T, where CPV is the specific heat at constant pressure for the water vapor, and the value is 1.82 kilojoule over kilogram degrees Celsius. This value is the average Cp value for the range of minus 10 degrees Celsius up until 50 degrees Celsius. And again, the temperature will be in the unit of degrees Celsius. Now we can have the expression of enthalpy is given by this equation. Note that the temperature will be the dry bulk temperature TdB, which is the ordinary temperature of atmospheric air.